open yours. All right, half equations. All right, so that pen's not going to work. This one will work. So what we're going to do is writing redox equations. We're going to go through that. We're going to practice that. Okay, and particularly we're going to do it in acidic medium. Now this is really important because this underpins a lot in batteries and cells, and they love to ask questions on this on the exam because students find it challenging, and it is difficult. All right, so balancing equation in acidic medium is really important. You might have done it a little bit last year, maybe a little bit. If not, we're going to go through it now. And then there's also in alkaline or basic medium. Okay, so we're going to go through this in a bit more detail, practice this a bit more, and then we'll use we'll do question 12, I think, as an equation of each other. All right. So the first thing that can be helpful is you write down what's undergoing oxidation, what's undergoing reduction, and then you're going to do you can balance all the atoms except hydrogen and oxygen. So this is in most textbooks, the same steps here. So if you haven't, if I'm going too quick, you'll have your textbook have it, your notes have it. Then you balance each half equation with oxygen atoms, and you do that by adding water to the other side. So if you have oxygen on the left and you have no oxygen on the right, then you add water to balance that, and I'll show you that in a minute. In order to balance the hydrogen, because it's acidic, you add hydrogen ions. So that's just like adding hydrochloric acid, but you're not adding the chlorine, you're just adding the hydrogen ions. And then you balance electrons on the other side, and then you don't need to worry about subscripts. And then this is an acidic. So sometimes you might have heard this as balance key elements, balance oxygen by adding water to the other side, balance hydrogen by adding protons to the alternate side, and then balance charge. And then the last thing is add states. So you might have heard this acronym, KOHES. Now, an acronym, we like them all, right? So there's the acronym, which could be helpful. So let's do it with hydrogen. Okay. Well, sorry, this is in alkaline medium. So we'll go through alkaline, and then we'll do an example. This is really important. This is a little bit challenging as well, but this comes up a lot. So if you're aiming for that top mark, aiming for that A+, or that high mark, you need to be able to do these. You need to be able to nail these, because these are the questions that separate students on the exam. These are the questions here that really put you into that high category, because they're complex equations in fuel cells or galvanic cells or electrolytic cells. You need to be able to do these in alkaline environment. So here's hydrogen going to hydrogen ions. So that's an acidic electrolyte, okay? Then you look at the number of hydrogen ions. So this is acidic at the moment. You look at the number of hydrogen ions on the left or right. In this case, they're on the right-hand side. And so now you add hydroxide ions to both sides of the equation. So here we had hydrogen ions. Now we're adding this hydroxide to the right-hand side to balance out the charge. But those hydroxides must have come from somewhere. So we also add hydroxide to the left-hand side. And so now it makes it alkaline. It makes it, you know, like a base, like a soapy flavor if you've ever had hydroxide. Then you see that those H+ and those OHs, they actually combine and they form water. So you have 2 lots of water because you've got 2 times hydrogens and 2 times hydrogens. So that's 4 hydrogens. So 2 times 2 is 4 hydrogens there. And then you have 2 lots of oxygens. So that makes 2 waters in this case. And then you keep the 2 hydroxides on the other side and you keep the electrons that were already there at the beginning. So that's the process on how to do an alkaline and an acidic. And they're very, very important. All right, and then this is the last one, electrons. So that's that E process, and then add states, so S, and then cancel anything common. So let's do an example. I wanted to go through. So very common, this one. You'll see this a lot. So here we have permanganate, MnO4, -1, going to manganese ions, Mn2+. So write the half equation for this, and it's in acidic medium, okay? So it's with hydrogen ions or it's with protons, they're called, if you don't remember that. So first thing, you balance key elements. So all elements except hydrogen and oxygen. Well, there are no unbalanced There are no unbalanced key elements. There's as soon as we finish this, we'll have a break. Yeah. All right, a short one though. Okay, because we need to we want to get through it. Okay, so MnO4 there's one of those, and there's one Mn2 plus ion. So key elements are balanced, so we don't need to do anything. So we move on past that step. Next step, you got MnO4, Mn2, same thing we just did above. Now you need to balance oxygen atoms by adding water to the alternate side. So there are 4 oxygen atoms on the left, so you need to add 4 oxygen atoms on the right-hand side by adding 4 waters. States are already included, but you don't have to include states at this point. At the end, you do. Then from there, you balance the half equation with hydrogen atoms by adding hydrogen ions. So there are 4 times 2 hydrogen ions. So therefore on the right-hand side, so therefore on the left-hand side, you need 8 hydrogen ions, which is what they have. And then you need to balance both with the charge. So if you sum the charge here, you've got, careful, it's -1 plus 8. So it's minus what or plus what? And then you've got plus 2 on this side. What's the charge on the left? It's a charge on the left. Plus 7. Make it a bit clearer. Plus 7. And we've got plus 2. So we need to make the charges equal. The charges don't have to equal to 0. The charges need to be equal to each other. And you can only make them equal by adding electrons. You can't add more positivity because you'll just get the ratios incorrect. So plus 7 plus x equals 2. So x must be -5. So -5 is going to be plus 5 electrons. Those electrons have a negative charge. That's how you do that one.